Okay, let's do another example where we're looking at specifically a 3-span moment distribution problem. All right, I'll get this drawn for us here. So this is a nice 3-span. Each span is just a little longer than the one beside it. And I've got 28-foot span. Oops, never mind that. 28-foot span on this one. This one's 32, and this one's 40. All right, and then we've got some loads on here. The first span is 3 kips per foot. Second span is 2 kips per foot. And third span is 1 kip per foot. This is actually on page 62 of your Bondi textbook, Bondi and Allred. So go ahead and go in there to find out how I got the distribution factors. Remember that K is 4 EI/Rel in the middle span and 3 EI/Rel in the end spans. And the other thing I would say is we're going to use the positive clockwise sign convention. He uses a slightly different method in sign convention, so that's one of the reasons I'm doing this problem is to do this the way that you were taught in your structural analysis class here, using the Hibbler book and that method, which is the most common one. All right, so we've got all the basics, and I'm just going to go ahead and start us right out into the table here. Joint, span, distribution factor. Then we have our fixed end moments, and that'll start our moment distribution piece. So I usually start by spans, AB, BA, BC, CD, or CB, CB, CD, DC, right? So these are the two B joint spans, and these are the C's. This is A, this is D. The distribution factors are here. We've got 1, 0.462, 0.539, 0.625, 0.375, and 1. All right, I go ahead and just put a, that's not very straight, but put a line through here so that I know where I am kind of along the joint. Don't get too confused, but you do however you're comfortable doing this. And then those are my ends. Okay, so fixed end moments, minus 196, plus 196, again these are all in the book, minus 170.67. The ones in the book just have flip signs because of the convention he uses. Get the same exact result though. The intermediate numbers that I do will also be different than the one in the book, but you will get the same results using the method we're used to. All right, so first things first, we start with the end pens, balance those. So 196, negative 196 times 1 times a negative. In other words, the joints, sum at the joints, times negative distribution factor, right? Same thing on the far side over here. And then those two joints are done and balanced, so we won't go back over there. We do need to go ahead and carry over. Carry these guys over. I didn't leave myself much room here. But this half of 196, remember 1/2 is 98. And over here, half of this is negative 66.67. All right, so now what I have is I've distributed those or carried those over from the sides. I need to go to each of the two interior joints and sum the joints. So I'm going to take these three numbers at joint B, and those three numbers added together times the negative distribution factor on this side gives me minus 56.98, and on this side gives me minus 66.47. I'm going to draw a line because now this joint is balanced. It means that all 5 of these numbers together should add up to 0. Do the same thing over here. Sum those 3 at joint C, and I multiply that by negative 0.625, and I get 18.33 and plus 11.00. And those should sum up to 0. What I would typically do is I distribute here from joint B to A, but I know I can't go back there, so that's not going to happen. I don't need to go to the outside. So the only distributing or carrying over I need to do is here and here. And you notice that is why they kind of call it the cross carryover, because I'm going between these 2 joints and it just kind of makes a X looking thing. All right, so if I take half of 18.33, I put it here. I take half of negative 66.47 and I put it over here. There's 33.24, and on I go. So minus 4.24 minus 4.94. Okay, those are 9.17. So now I only just have this one thing at the joint. After the first couple rows, it gets much quicker. And I'm distributing. When I add those 4 numbers up, they should be 0. Same thing over here. 33.24 negative times a negative 0.625. And I get plus 20.77 and plus 12.47. All right, so this is going to go on and on for a little while, so I'm going to continue to do this, and I'll kind of call out what I'm up to. So 4.94, I'm going to move this up for us a little bit. 4.94 minus 2.47, and over this way I get plus 10.39. I distribute those guys, minus 4.79, minus 5.60. Draw a line. Over here, distribute this one, and you can see this one's getting small fast, which is great. It just depends on the problem and the loads, how fast this goes to 0 or towards 0. All right, so if those are balanced, do another crossover. And you can see, since I'm crossing over and getting half each time, this starts to get a little faster. Distribute. Those 3 numbers add to 0. Come over here, 5.60. Half of that is minus 2.80. I'm going to distribute. And typically I'll take this until I'm only adding about a 10th place, depending on the size of the actual loads and moment. So I'll just take this one out a few more steps, and you can see how this goes. 0, and over here we get 0.21. When you're rounding and you're getting to these smaller numbers, I kind of round up one side and one down the other, so that these 3 numbers at the joint actually sum. Looks like I've been a little neater on one side than the other. I'm going to move this up. Otherwise we're going to have a mess on our hands. So this was minus 0.21. There we go. I'm not being particularly neat, and I probably should be. Alright, we're down to the wire here. We're starting to get into fairly small numbers. So you can keep this going as long as you want. I usually, like I said, go out to about the 10th place. So over on the left I'm doing good, but I need to get a little bit further on the right here. So minus 0.24, and that gives me 0.15. And that balances. Alright, one more. And I'm going to get plus 0.07 again, and minus 0.03, minus 0.04, and on the right, and I'm going a little fast because I'm afraid my recording will give out on me. On the right, minus 0.02, and this actually, okay, so look, we're good now. We're in past the 10th place now into the 100th place, which is actually great. If I sum these all up, so now I've balanced, I'm as good as I want to be right now. Sum these rows up, and you sum all those numbers up, and you're always really happy when you find out that they are equal and opposite. And so this is what I get when I sum these up. If they're not, you need to go back and see where you made a mistake. A lot of times it's just plugging that stuff into the calculator that makes the mistake, where you make the mistake. All right, so we've got the final values here, and we know the moment diagram looks something like this for that type of loading. And these are going to be my interior negative moments. And he's got his drawn, I believe, on the other side of the moment diagram, but this is what you've learned with negative moments, positive moments, which are the smiley faces, and you can draw the deflected shape. And now you could draw, so this is the moment in Kip Feet. You can also go ahead and find all the reactions.